So hey guys, welcome back to my channel. Hope you are doing extremely well, and this is your very own Mascode at this side. So from this lecture, we are going to start with the topic of heaps, right? Hope you are all excited. So heap, what is a heap? So it is a binary tree based data structure. It is a binary tree based data structure. First of all, it is a data structure which works on the principle of binary tree. That is, the data stored in it is in the form of binary tree. We have already studied about binary tree, right? Now, this binary tree should satisfy the heap property. This binary tree should satisfy the heap property. What is that? So, we have studied about binary tree, right? We have studied about one type of binary tree which is known as BST. What is the property of BST, by the way? The property of BST says that every value in the left subtree should be less than the value of node, that is a root, right? You can say the node, you can say the root, and this all values should be less than the every value in the right subtree, right? This is the property for BST. Similar to this, there is a heap. Now this heap property says the value of each node should be greater than or equals to, or you can also say lesser than or equals to the value of its children. And this property makes sure that the root node has maximum value and the value decreases as you move down the heap. So those of you who are not able to understand, the heap property says this simple thing. We know that there is a binary tree. That means there is a node and it has some children, right? It has a node and there is some children, right? This is my node. This is child 1. This is child 2. The property says nothing but the node value should be greater than child 1 value or equals to also, or should be greater than equals to child 2 value. This should be an AND operation, right? It should be greater than child 1 value and child 2 value. There is no relation among the child 1 value and child 2 value. They are not at all related. They are just related to this node by the case that node value should be greater than child 1 value as well as child 2 value, right? If this child has again a1 as its children and a2 as its children, then this or these two nodes should be lesser than the value of child 1. They can be lesser or greater than the child 2. That doesn't matter to me, right? They are not at all related to this child 2, right? Siblings are not at all related. They are just related to the descendants, right? So if you see, if this value is greater than child 1 and then a1 and a2 are lesser than child 1, that means node is the greatest. Node is the greatest value. Node is the greatest value. This is all about heap. This is only the heap property. This is the heap property. You just have to see the node and its children and its children. Also, it is based on a complete binary tree structure. Complete binary tree structure. What do I mean by that? So it is not possible here. 1, 1, 1, 1, and again 1. This is not possible in a heap. Heap always constitutes something like this: 1, 1, 2, 1. So here are 1, 2, 3, 4, 5 nodes. So 1, 2, 3, 4. Fifth node will come here, right? It will be a base of complete binary tree. These are all the problems which can be asked to you in an MCQ section of an OA, or interviewer might ask you to break some ice over the interview, right? So these are some properties. Now, I told you that in the heap property, node value should be greater than child value, children value, I can say children value, greater than equals to, right? This is one type of heap. This is one type of heap. Second property says node value should be less than children value. This is second type of heap. So if your heap is following the case, this is second type, right? So if your heap is following this property that node value should be greater than equals to child value, then this heap is known as max heap. This is heap is known as max heap. And if it says that node value should be less than equal to children value, it is known as min heap. It is known as min heap. Now I'm going to draw two trees, two heaps to be accurate, and you will have to tell me which one is max heap and which one is min heap. So suppose my first heap looks something like this: 10, left child is 15, right child is 30, 40 here, 50 here, 100 here, and 40 again here. And similarly, there is another heap with 100 here, 40, 50, 10, 15, 50, and 40. Right. Now it is your quiz to tell me which one is max heap, which one is max heap, and which one is min heap. Let us analyze it. Let us analyze it. So we just studied that for the max heap, node value should be greater than the children value. Let us analyze the first one. 10 is greater than 15. No, 10 is not greater than 15. So it is false. Max heap cannot be this. Let us try it for this. 100 greater than 40. Yes, 100 is greater than 40. 100 greater than 50. Yes, 100 is greater than 50. For 40, 40 greater than 10. Yes. 40 greater than 15. Yes. 50 greater than 50. Yes. 50 greater than 40. Yes. So that means it is a max heap, right? Okay. Talking about min heap, let us analyze for this. 10 less than 15, yes. 10 less than 30, yes. 15 less than 40, yes. 15 less than 50, yes. 30 less than 100, yes. 30 less than 40, yes. But this is a min heap, right? So I hope you were able to distinctify that which one is the max heap, which one is the min heap, right? Now, if you look closely in the case of min heap, this is the min heap, of course, right? You can see that if as I'm going down, the value is increasing. The value is increasing as I'm going down. So you can say that if 10 is less than 15 and 10 is less than 30, and subsequently the value is increasing, this is my minimum element. This is my minimum element, right? This is the property of mini heap, that the root of the tree is a minimum element. Root of the tree is minimum element, right? We write it down there. Root of the heap is minimum element, right? Second property, second thing, max heap. If you see that as I'm going down, the values are decreasing. The values are decreasing. So you can say that 40 and 50 are less than 100, and the subsequent values are also less. That means 100 has to be my maximum element. 100 has to be my maximum element. So this property says root of the heap is maximum element. Right, these are some two properties of the max heap and the min heap, right? So max heap comes from this only, that the max words comes from this, that root is maximum, and min comes from the word that the root is minimum element, right? So I hope you are clear with the heap, its type, that is max heap and min heap. Clear with max heap and min heap, you are clear with the heap. Now, why do we use heap? Why do we study about heap? That is also a cooperation, right? Why do we study about heap? Why to study about heap, right? This is the question. And the answer to this question is somewhat like this. Suppose I have given you an array. Suppose I have given you an array, something like this. 1, 5, 6, let's say 4, 7, 3, and 10. Right? I tell you that this is your array, right? And I want the maximum from it. I want the maximum from it. I want the maximum from it. What does it mean? What does it mean? I say my operation is that insert one element in the queue. In the queue. That is, take a queue with you. This is empty right now. Insert element. So if I insert 1, what is the maximum element in the current queue? This is my queue. The maximum element in the current queue will say there is only one element, 1. So I will say yes, 1 is correct. Right? Now talking about 5. Talking about 5. As soon as you insert 5, the maximum element becomes 5. Correct? As soon as you insert 6, maximum element becomes 6, right? As soon as you insert 4, element 6 is again the maximum. Element 6 does not change, the maximum element doesn't change. As you insert 7, 7 becomes the maximum element, right? For 3, 7 remains the maximum element. For 10, 10 remains the maximum element. 10 becomes the maximum element, right? So you can see that whenever you are using the sequence of data stream, we want to find maximum or minimum. in the currently processed stream, in the currently processed stream, we use the concept of heaps. I hope I'm making a point here. Whenever we require, like you can also say that I will just keep a maximum variable and update it, right? But there are some very different questions where you have to keep like in a sequence, and priority queues or heaps will be used a long way. We will see in the upcoming videos. So it is one of the use cases that whenever the sequence stream is changing and we want to find the maximum or the minimum, we can use the max heap and min heap respectively, right? So there comes the heaps collectively. Why does the heap come there? Because heap gives us a like what do we say, advantage. What is advantage? So heap gives us advantage of finding the maximum, finding the, let us say not the maximum or minimum, let us say extreme, right? Finding the extreme in O of log n time. In O of log n time. Why? Because as soon as we insert an element, this element gets inserted into the heap at the correct position and we get the maximum and the minimum respectively in O of log n time. Like that is I'm saying the operation of inserting an element into the heap into the heap is O of log n, which actually saves a lot of time, but otherwise you will have to go O of n, so the time complexity will become O of n square, something like that, right? So let me write down the operations we can perform on the heap. Operations of heap. So first operation, as I told above, insert. You can insert element into the heap, right? It is the important, most important part. Otherwise, what is the use of studying heap if we cannot insert elements, right? Second, extract. Extract the extreme element. Extreme element. For those of you who are not even understanding what is the meaning of extreme, so for max heap, extreme means maximum element, and for the min heap, extreme means the minimum element. I hope I'm making a correct point for you, right? Okay, so you can insert elements, you can extract elements. Extract means extract the extreme element means get the maximum element out of the heap and delete from the heap also. Delete from the heap as well. And the third, heapify, right? What does heapify mean? That is, given a binary tree which is not a heap right now, we can convert it into a heap. This is also a heap operation, right? This is also a heap operation. These are the three most important heap operations, right? Fourth operation is peek. That is, just get the maximum element, just see what is the maximum element, but do not delete it. Just see the maximum element, but do not delete it from the heap, right? Okay, these are the operations of heap, right? This takes O of log n time. This takes O of log n time. This takes O of 1 time. This takes O of n log n time, I guess, right? Okay. Now, where do we use heap? Where do we use heap? The advantages, the operations, the exemplary set operations, right? So first one, it is used to implement priority queues. It is used to implement priority queues. Now, what are priority queues? So as you can see, the heading of the video was at heaps slash priority queues. They are exactly same. The operations are exactly same. So in the C++ STL, heaps are offered as priority queues. Heaps are offered as priority queues. So the syntax something like this: priority queue of int, and let us name it as pq. This means a heap of priority queue is made. The name is assigned as pq, and you can store integer into it. You can store integer into it, right? This type of operation, like this type of assignment, gives us a max heap. That is, the top element of the priority queue will be the what do we say, the top element of the priority queue will be the maximum element in the heap, right? And if you want the minimum heap, so it is somewhat of a long operation. You will have to write like priority queue of int, vector of int greater of int 1 2, and you will then close it, and it's known as priority. This is the min heap. This is the min heap. That is the small top element is the minimum element, right? So first operation is this. Second operation, heap sort. That is, we know about sorting, right? We know about an array getting sorted. So heap sort is also a sorting technique with the use of priority queues. What do we say? We just insert the elements and then pop the elements out. Insert the elements into a mini heap. If you want ascending order, into a mini heap, and then pop them out one by one. Pop them out. Insert all the elements, right? Pop them out one by one. As simple as that. How is that possible? So suppose for the given tree, this was a tree, right? Suppose I started inserting something like this, jumbled, right? Jumbled. And if I assign them in jumbled order, the heap will reorganize itself in this format. So for n operations, for n insertions, each will take log n time. So log n will be the time to store the numbers into the heap. And now in O of n time, I can just pop them out and I will get the heap sorted order. This is known as heap sort, nothing else, nothing different, right? This is known as heap sort. Third, and the last I'm going to tell you, it is used in many graph algorithms like Dijkstra uses it. Dijkstra algorithm uses it, and Prim's MST algorithm uses it. Prim's algorithm to find the MST, right? Like priority queues and heaps have a very extensive use case, so we will not go into why are they important because we know they are important, right? Okay. So I hope you are clear with the heaps, you are here clear with the priority queues. One more thing I want to tell you, that how are heaps stored? How are heaps represented actually? Heaps represented. So I told you that they are in the form of a binary tree, right? I drew an example also. Suppose this is my min heap 10 connected to 15, connected to 20, 15 connected to 40, 40 connected to 50, 20 connected to 100, and 40, right? So we just, like in the earlier section of the video, we just encountered that this is a min heap. We just configured that which is a min heap. There is no problem in that. Now I want to tell you how is this stored? Like how can you represent a heap? So you are saying that binary tree is representing, correct? But you can also represent it in the form of an array. Shocked, right? You can also represent it in a form of an array. How? So suppose this is your array, you will just have to write 10 level order traversal. Write the level order traversal. Right, this is the main reason why I wanted you to make a heap as a complete, right? 10 complete binary. So 10, 15, 20, 40, 50, 100, 40. Now you will say how is this array equivalent to this binary tree, right? So let me make a connection. So this 10 is connected to 15 and 20. This 15 is connected to 40 and 50. This 20 is connected to 100 and 40. So if you see, the indexes are 0, 1, 2, 3, 4, 5, 6. Index 0 is the parent of 1 and 2. Index 1 is the parent of 3 and 4. Index 2 is parent of 5 and 6. Are you able to understand what I'm saying? So ith index is the parent of 2y plus 1 and 2y plus 2. Similarly, 1 is a parent of 2 into 1 plus 1, that is 3, and 2 into 1 plus 2, that is 4. 2 into 2 plus 1, that is 5. 2 into 2 plus 2, that is 6. Are you able to understand? I can write it as 2 of I plus 1 minus 1 and 2 of I plus, right? Same thing, right? Same thing. Okay, so this is the all about heap you want to know, right? If some of you want to know how to implement it in VS Code, how to implement the code of heap, implement the code of heap. If you want to know about that, like it is not gonna be asked to you in any interviews, etc. And you will not be writing the code of heap, etc. Because you will just be using priority queue in the STL, right? But if you genuinely want it, just comment it down and I will bring out a video implementing all the functions like insert, extraction, peak operation, deletion, etc. And I will bring out all the concepts for you in a single video. Just implement the VS code for it. Otherwise, you can also check the GFG articles. They are also particularly well how to implement a heap, right? So I hope we can end the video here. You're clear with the heap. Just remember at the last that heap is this value of each node greater than or equals to value it is children. That is simple, right? Greater than or less than, that is your way how you want to use it, right? Now it is time for us to end the video and we'll meet in the next video. Till then, stay tuned, and if you are not subscribed, subscribe to the channel because you are now gonna see a beautiful playlist on the heaps that has not been uploaded on the YouTube till now. Okay, thank you, have a nice day.